Welcome to Single Phase Motors video part 6. Today we are going to discuss about universal motor. We are seeing the socket. Can we call it as universal socket? Why universal socket? Because this socket can be used for both Indian type of plugs and foreign type of plugs which is having square shape of pin. So both the things can be used in a single socket, and that is the reason it is known as universal socket. So it can be used for two different standard plugs, that is known as universal socket, and this motor is known as universal motor. Why it is known as universal motor? The picture you are seeing a motor used in mixies and all, universal motor. Why it is universal motor? Because it is working in both AC and DC. The same motor with the same voltage you will be able to operate in AC and DC. That is the reason it is known as universal motor. And let us see the parts in the universal motor. Here the stator core you will be able to see. Which is the stator core? This item. This is the stator core which is laminated. Laminated, maybe steel metal item. What is the function of this item? It is holding windings and providing a path, magnetic low reluctance path it is giving. This is known as stator core. Okay, the next is field winding. This is one winding here and this is another winding here. So it is only a one winding, but it will be provided as two separate sections, so independent sections. So you are seeing the field winding, only one winding is available but given as two sections. And the third thing, it is the armature, the rotating part here with the winding, it is known as armature, and armature shaft is extended. Armature is known as armature, which is having the bearings here and it is rotating. And next is the commutator. Commutator here you will be seeing in DC motors and in AC motors. This is the commutator type of motor, the universal motor. So there is a commutator. And what is a brush holder? The brush, it is held by, or it is giving two purposes. It is adjusting the brush of the brush, and it is holding the brush. It is known as brush holder. And next is brush. Obviously brush, the black item, generally it is a carbon brush for the universal motor. And a fan, it is attached to the shaft. This is the shaft, this is one of the bearing, and this is the fan, as you know. And they will be seeing where it is being used. The mixie, in mixies universal motors are being used. The universal motor, it is a very high speed motor. What is the speed of the universal motor? Generally it is around 12,000 to 18,000, generally around 15,000 we can say. Normal motors operates at 1500 rpm and all, like CSIR and water pumps and all. General roughly we'll be able to tell 1500 rpm. And PSC motors used in ceiling fan and all, it will work around 300 rpm ceiling fan or table fans and all. And the mixie, it is the high speed motor, and universal motor, it is a 15,000 rpm. Why this much rpm? And that is the reason why your items like vegetables, like other seeds and all, getting ground because of this high speed. This is not the only the reason, that is the blade sharpness, including the sharpness of blade and plus the speed of the motor was important. So that is the speed of motor around 15,000 rpm for universal motor. And also it is widely used for drilling machine. These are few applications only. The induction the universal motor is finding many applications in AC. And the parts are again once again told like this. Let's just see the shaft part. It is here, shaft one, it is shaft, and second is field coil. You will be able to see two sections of field coil. One field winding is there, the one field winding will be splitted into two, and one is in the upper part and one is in the lower part. Why it is given? It is in the two sides of an armature, and armature is available here. This is the fourth part, armature. Armature, it is covered totally. That is the reason the field coil, it is made to have better flex to the armature. Okay, so the field coil is available in two sections, and this is the rotating armature. The armature has to be covered by this field coil, so it is split into two. And commutator, you will be able to see this is the commutator. Sorry, and before going to the next slide, brush holder is available. Brush holders, both sides are brushes are holding by this brush holder. and it can adjust the temper also or tension also. And 7 is the bush bearing. Bearings are already there because one rotating part is there, fixed part also is there. To make both the things together, we are having a bearing, and the low cost bearing, which is known as bush bearing, it is used here. Bush bearing, ball bearing, roller bearing, different type of bearings are there. The low cost item, it is bush bearing and used for such universal motors. And carbon brush is available here. Carbon brush take the current into the armature from the field coil and take it back to the next section of field coil. So this is the connection. This is used for both AC and DC, and we can see the current it is going to the first part of the coil and going to the brush through the commutator to the rotor conductor and to the next brush and going to the next section of the field coil and back to the supply. Let us see the motor working as a DC motor. You know the DC motor working principle. Whenever a current carrying conductor, here it is the rotor. Whenever a current carrying conductor placed in a magnetic field is available. So whenever a current carrying conductor placed in a magnetic field, it will experience a mechanical force or it will rotate. Okay, because of the continuous giving of conductors in the rotor and the field provided by this field flux, this rotor of the DC motor will rotate. So this is the working when universal motor is given DC supply. So it is normal DC motor operation with respect to the working principle. And let us see the working of universal motor in AC. Universal motor working in AC will be explained now. DC motor, as DC motor was, it will be working for universal motor. But AC, it is having two positive and negative half cycles. We are going to see one by one. The positive cycle working and then negative half cycle working. In this case, we'll be considering only positive half cycle. Okay, what is happening under positive half cycle? So let us see the current, how it is going. From the positive part, it is going and it is going to the armature and next section of field coil and returning. So this is happening in positive half cycle. So what are the conditions? There will be a direction of current through the armature, it is towards the bottom, and there will be a polarity in the field coil depending on the current. So it is left to right. How it is? There are two things. From the left to right, your field flux is available from north pole to south pole. Obviously, it will be like that only. From N to S, the flux is flowing, and in this picture, you will be able to see this is the direction of armature current. Both are fixed, and based on that, we are taking the Fleming's left hand rule, which is motor action. There is a magnetic field, there is a direction of current, and we will be getting the direction of movement. So direction of movement of conductor, let us say this is the upward part. This will be continuing in the counterclockwise or anti-clockwise part. Anti-clockwise, the rotor will rotate. Okay, so based on the Fleming's left hand rule, we are having the magnetic field like this. So this is the magnetic field in the motor, and there is a direction of current in the Fleming's left hand rule. Then this is the direction of left hand rule, and based on that, the conductor movement will be upwards. Let us say here it is moving in the anti-clockwise direction. So this is happening in which half cycle? Positive half cycle. Now we are just changing into negative half cycle in the bottom picture. Now you can see negative half cycle it is come, because the half cycle is negative, there will be changes. The polarity now N to S it is changed, and from S it has changed to N, because the polarity of direction or polarity or direction of current is changed. Then polarity of field will change. What happens to polarity? Field previously N to S is like from left to right, here it will be right to left. The polarity has changed. Similarly, we can see the current in the armature, it was in this direction in the upper part of the positive half cycle, but in the negative half cycle what happens? In the negative half cycle it is in the upper direction. So the field polarity, let us say this is N to S in the upper part, and in the lower part this is N to S in the right to left, and the current in the upper part in the bottom part, and in the bottom picture it is upper direction. So these are the direction changes. Now let us change the left hand rule like this. Only this again the left hand only, the left hand rule still applies, previously magnetic field was in this direction, now it has changed to the opposite direction. And the magnetic field direction of current, we can say, not direction of current, it is in the towards us, and here it is against us, it is going away from us. So the direction of magnetic field and direction of current is changed. Still what happens, still the direction of conductor is same direction. So direction of movement of conductor, direction of motion, it is in both the cases direction of motion of conductor will be the same. So in universal motor, if in positive and in negative half cycle, in the positive and in the negative half cycle, what we can understand, we can say that the direction of the rotation, remains the same. Okay, you can hold your hand, left hand as picture 1 and picture 2. You can see in the both condition, even the magnetic field and direction of current is changed, the thumb still will indicate upwards, or the direction of motion will be the same. So the direction of motion in uniform will be uniform in the same direction for the universal motor. So we can say that the universal motor will work in AC. It is not requiring any additional winding like starting winding and running winding. Universal motor is self-starting with only one winding itself. So this is the working of universal motor when AC supply is given. Now the next question is, how we will be able to change the direction of rotation of universal motor? This answer is simple. You can change the brush positions or interchange the connection of armature. That is the best method. By interchanging the direction of currents or interchanging the brush terminals, we can change the direction of rotation. Now you can see the anti-clockwise direction of rotation here. In the next picture, what you are seeing, it is a clockwise rotation. What are the changes happened? The current direction was previously in this direction. Now it has changed to upper part. Okay, or just inverse direction, opposite direction. How it is achieved? You can see here it is V2. The V2 in the previous picture or the first picture, it is connected to A1, and in V2 it is connected to, you can see that it is changed to A2. V2 is connected to A2, and here it is U1. U1 is connected to A2, but here this U1, it is available here, U1 is connected to A1. So A1 and A2 terminals are interchanged. A1 and A2 terminals are interchanged in universal motor, that is armature terminals are interchanged in the universal motor. Then we can change the direction of rotation, but you should not change the field pole connections. The method is like this. For changing the direction of rotation of universal motor, you can either change field poles or the armature connection. There are two sections of field, it is bit difficult, so it will be easy to change the armature only. Generally that is the method. To change the direction of rotation, we should change only armature. In mixie and all, as a technician, we should not change the direction, because the mixie direction should be same before repair and after repair, because the blade is having sharpness in only one side. That should be the direction of rotation. If you are changing the direction of rotation mistakenly, it will not grind the items and all, so it will not work perfectly. So the technician should ensure that the direction of rotation is properly set. The armature connection may be changed, armature may be tested and all, it should be properly reconnected. And in the hand drilling machine and all, the new drilling machine, what happens, you can easily change the direction of rotation. To unscrew, for drilling you can put it in one direction, and unscrewing operation, it is the opposite direction. For that you are just moving a lever. What is happening there, we will be changing the lever to change the direct connections, interchange the connections of armature terminals. And we will be having comparison with universal motor to DC series motor. What is universal motor? It is AC and DC operable motor. It can be used both AC and DC, but DC series motor can be used only under DC. If you are using an AC, it will be having heavy sparking at brushes due to its rough commutation. The commutation is not proper. So compensating winding, you have actually not discussed. There is a winding additionally known as compensating winding for universal motor, especially for bigger capacities, and it is not required for DC motors. And interpoles also available for bigger capacity universal motors, and it is not that much required for DC series motors. and high resistance grade brush. It is required for universal motor because to improve the commutation we use resistance commutation, and for DC series motor it is may not be required. And air gap for AC motors, the magnetic flux leakage will be there more because the flux itself is changing in the stator, so we have to use air gap minimum. And for DC series motor, normal air gap is sufficient because the field poles are having permanent magnetic field. Permanent in the sense that it is not varying, it is or alternating, so it need not create a very narrow air gap. Air gap can be normal. So these are the differences between universal and DC series motor. Thank you.